This was a review that they gave us about 5 weeks ago, so I'm thinking they might try to sneak one of these problems onto the CBA. This top one's not that bad. We've done this problem. What do you have to do to 3p squared plus 7p minus 20? What do you do to this? You factor it. What does that factor into? What now? Give me the final factors. 3p minus 5 and p plus 4. After you factor that, that's what you should get. Okay, it's basically what we're doing is dividing by p plus 4. We know one of the dimensions. If you divide this by this, you find the other one. So what's the missing dimension? Right, this is the answer. The length would have to be 3p minus 5. You don't know how we got that? Okay. First of all, this is the area. That means two things got multiplied together to give that area, a length and a width. They told us what the width is. They're asking us to find the length. They want us to find the missing dimension. Let's do this with let's just do this with numbers instead of with polynomials for a second. Let's say I told you that the area is 40 and I just told you that the width is 4. What would the length have to be? 10, because 40 divided by 4 is 10. The area divided by one of the dimensions gives you the missing dimension. Now, how do we do this? We're going to learn two ways. The first way we learned is you factor this. Okay, so you got to go through that process of finding the factor pairs of negative 60 that could add up to a positive 7. You got to go through that whole process. I skipped all that. I just went to the answer. Yeah, after you factor this, you got to do the work to factor it, which that's not new. You should know how to do that. That's going to come out to p plus 4 times 3p minus 5 after you go through all that work. So we know that the width was p plus 4, so what was the missing dimension if these cancel out? 3p minus 5. Yeah, I skipped the factoring part. That's the part you should know how to do. Alright, now number 2 here is a little bit different. How would I factor that? GCF. What is the GCF? Okay, so we're going to take out a 5x, and what's left is 2x minus 17. Now we're dividing that by x. Now this is a little tricky. We are going to cancel out any common pairs of factors. Do you see anything that could cancel out? No, 5x and 2x are both on the top. You can only cancel out bottom to top. Yeah, the x's. This x is going to cancel out with only this x. Factors can only cancel each other out if they're factors. Factors have to be connected by multiplying. This x right here is not connected only by multiplying. Do you see how it's attached to a minus 17? So the only thing that could cancel this out is if we had another 2x minus 17. Well, if we distributed, we'd end up right back where we started. We factored this out so we could recognize that, hey, there is a common pair of x's that can now cancel out. So the answer is 5 parentheses 2x minus 17. That's your final answer. Okay. Now, another thing that they like to do is take something simple that we know how to do and try to make it look scary or complicated. Look at number 1, and they might write the directions as telling you to expand this. They want to expand this. That just means multiply. That's a binomial being squared. Remember, you cannot do that in your head. You've got to write it out side by side. So this would be 1/5 plus 4x. Oops. 1/5 plus 4x times itself. 1/5 plus 4x. They tried to make it look scary with fractions. Your calculator can multiply fractions. You just need to put it in as a division problem. 1 divided by 5 in parentheses times 1 divided by 5 in parentheses. Or you could think back to 5th, 6th grade math. What is 1/5 times 1/5? Oh my goodness. 1/5 times 1/5 is 1/25. You do top times top and bottom times bottom. Not when you multiply. Oh no, when you add, denominators don't change. But when you multiply, it's top times top, bottom times bottom. Okay, let's say you forgot that. You can get your calculator to do 1/5 times 1/5. A fraction needs to be entered in parentheses, though, as a division problem. There's 1/5 times, times 1/5. It's going to give me a decimal answer, but then I can get my calculator to convert that to a fraction. Or you could just remember 4th and 5th grade math. 1/5 times 1/5 is 1/25. Okay, so it's not bad. Okay, so 1/5 times 1/5 is 1/25. Now 1/5 times 4x. Now remember, how do I make 4 look like a fraction? 4 over 1. So what's 1 over 5 times 4 over 1? 4/5. So 1/5 times 4x is 4/5 x. Now, what's 4x times 1/5? We do the whole thing again. No, 4/5 x. And what's 4x times 4x? 16x squared. So even though it had fractions in it, let me just make some space here. Even though it had fractions in it, it's not that hard to do, and the calculator can actually do it for you. That's the answer, but we got to clean it up. Look at the middle two terms. Now this is where you're adding fractions. What's 4/5 x plus 4/5 x? 8/5 x. So the final answer is 1/25 plus 8/5 x plus 16x squared. That's the answer. All right, and then the volume of this rectangular prism. There was one like this on your bonus on yesterday's daily grade. Volume is length times width times height. So you've got to do x times x plus 2 times x minus 3. And some of you were trying to multiply 3 things at once. You can't do that. When you've got a long string of multiplying, you multiply 2 things at a time and get an answer. And then you take that answer and multiply it by whatever's left. So I could multiply these two together and then multiply by x minus 3. Yeah, I usually do the binomials times each other first, and then I'll deal with the x. So I'm going to leave this alone, and let's deal with this. What's x times x? X squared. Then you get negative 3x. Then you get positive 2x. Then you get negative 6. So add up your middle terms. That's x squared minus x minus 6. Now I still have to multiply all that by x. X to the third minus x squared minus 6x. That's your final answer. If you have 3 x's that are going to get multiplied, then you should always have an exponent of 3. Well, you must have messed up on something else if you missed it yesterday. All right, so that's 4 types of problems that you might possibly see on your CBA. And here's the one last lesson that we need to make sure we get in today. Yeah, it actually probably is the last new lesson of 2016. And it's dividing polynomials, but this time there's a hitch. We did it yesterday or 2 days ago by factoring. Today you cannot factor. They're not going to be factorable. They're going to have a remainder, in other words. So we're going to have to do this using long division. Once you catch on, it's easy, but you got to pay real close attention. Dylan, put that down. Let's just start with our first example here. Two x squared plus 9x minus 13 divided by x plus 6. Just in case, you should be familiar with the words that represent a division problem. What you're dividing by is your divisor. What's being divided is the dividend. The answer is the quotient. And we're also, in these problems, we're going to have a remainder. Remember, sometimes when you divide, it doesn't always work out to go in nice a whole number amount of times, and that's what's going to happen today, unfortunately. Okay, if you tried to factor this problem, it's not going to work. It's not factorable. The problems I'm giving you today are not factorable. So you have, no matter how they're written, tonight's homework, I ran out of space when I was writing it on the board. So for some of them, I wrote them like this. But let me just tell you, on your homework tonight, you cannot factor. So no matter how it's written, you're going to have to rewrite it with the long division bar. No, because you can't do it by factoring. All of the problems I'm giving you for homework cannot be factored. Okay, let's just try it. What's 2 times negative 13? Negative 26. That's 1 and 26, or 2 and 13. Is that ever going to make a 9? No, these are not factorable. You can't factor them. So we're going to have to do this by long division. So let's see what happens here. I think this is fun. You're going to like it. Okay, you always look at the first two parts of the divisor and the dividend. How many times will x go into 2x squared? In other words, what would you multiply by x to equal 2x squared? 2x. So I put a 2x up here. Now I have to multiply that 2x by the divisor. Multiply 2x by what you're dividing by the divisor. What's 2x times the whole entire divisor? 2x times x is 2x squared. That's what I wanted. I don't want to have any remainder right here. What's 2x times positive 6? Plus 12x. Okay, now this is how division works. Long division works by you figure out how many times it will go in, and then you subtract what's left, and you keep bringing down the next numbers. So now we're going to have to subtract these two things. Oh, it is 12x. I'm sorry. That's 12x. That's what I meant to put. Good eye. Good eye. Okay, so let's back up, if I've already lost you. You look at the first part of your divisor and the first part of what you're dividing into. This and this. You ask yourself, what do I multiply x by to make it 2x squared? Well, that's 2x. So I put a 2x up there. Now, I have to multiply this by everything I'm dividing by. That's where I get the 2x squared plus 12x. Now I subtract to see what's left. 2x squared. Now this is where you got to be real careful too, because subtracting negatives gets tricky. This one's a positive minus a positive. It shouldn't be that bad. 2x squared minus 2x squared is what? 0. Well, that's what we want, a 0 there. But we're not going to get a 0 here. What's 9 minus 12? Negative 3x. Now bring down what's left. What's left? Minus 13. Always look at your first part. Your x and your negative 3x. What goes into, how many times will x go into negative 3x? Negative 3 times. So I put a negative 3 up here. And now I have to multiply that negative 3 by the entire divisor. So multiply negative, because you're trying to go, you've already got an x. X times what would give you negative 3x? X times negative 3 would give you negative 3x. So negative 3 times x gives you negative 3x. You always want this to equal out to a 0 when you subtract. And what's negative 3 times positive 6? Negative 18. Now here's where you've got to be careful. Negative 3x minus negative 3x? 0. Negative 3 minus negative 3, negative 3x minus negative 3x, those cancel each other out. But this is where you got to be careful. You might want to have your calculators handy because you're subtracting. You're always subtracting what you multiplied. What is negative 13 minus negative 18? Positive. Oh, negative 13 minus negative 18 is positive 5. That's my remainder. I don't have anything else to bring down. That's my remainder. So the answer is 2x minus 3, remainder 5. Just put remainder 5. Your goal is to, when you run out of numbers to bring down, you're done. And if this didn't equal a 0, then you've got a remainder. All right, let's try another one. Number 2. 3x squared minus 23x plus 7 divided by x minus 7. You always want to look at the first term of your divisor and your dividend and ask yourself, how many times will x go into 3x squared? 3x times. You want this times this to equal exactly what you have here, so they'll cancel out when you subtract. So now you got to multiply 3x times all of x minus 7. What's 3x times x minus 7? 3x squared minus 21x. Okay, so now I'm going to subtract to see what's left, and then I'm going to keep bringing down what I still have to divide into. This should always equal a 0. Your first two terms should always cancel each other out. I multiplied 3x times x minus 7. In a minute. What's negative 23 minus negative 21? Yeah, negative 23 minus negative 21 turns into negative 2x. Now I bring down the plus 7. How many times will x go into negative 2x? Negative 2 times, right? What's negative 2 times x? Negative 2x. What's negative 2 times negative 7? Not negative 14. Positive 14. Then you subtract and see if we have a remainder, which we do. 7 minus 14 isn't 21. You're always subtracting. That's how division works. You always subtract what's left and bring it down. 7 minus 14 is negative 7. So the answer to this problem is 3x minus 2, remainder, negative 7. Okay, let's do another one. You always try to go first term into first term, and then you multiply that by both parts of the divisor. That's what you're always doing here. Okay, now on your homework, no matter how I wrote it on the board, I am telling you right away that you cannot factor these that I'm giving you. So even if it's written like that, let's rewrite it as a division bar. I'm telling you, you can't. It's not going to be factorable. All the problems I'm giving you today, Brian, are not factorable. Okay, so we're doing 3x squared plus x minus 5 divided by 3x minus 5. Do we need to do this one together? All right, some people are saying yes. If you don't need me, then just... Okay, 3x will go into 3x squared. 1x times. What is x times 3x minus 5? 3x squared, then what? Minus 5x. Chris, did you see where I got that? You always multiply this by your entire divisor. Then you subtract those two amounts. The first two should always cancel out on this step. Now, you got to be careful with your signs here. This is 1x minus negative 5x. 1x minus negative 5x is positive 6x. And then bring down the rest of this. Bring down the minus 5. How many times will 3x go into 6x? Right, you're trying to go here into here. 3x goes into 6x positive 2 times. Now you got to multiply that 2 by 3x minus 5. And you'd get 6x minus 10. Now you subtract, and whatever you get, that's your remainder. Negative 5 minus negative 10 would be a remainder of 5. So the answer here was x plus 2, remainder 5. Okay, the homework. The book does, this is new. This is the first year I've taught this. This is something that's never been in algebra before this year. So I just have problems that I had to make up for you. It's not in the book. So copy these. Now look at 5 through 8. I just wrote them like that because I was running out of space. I'm telling you, you cannot factor these. So when you're writing 5 through 8, I would just go ahead and write it with the division bar. I'm sorry, with this symbol. Well, however much space it took you to do the notes. Then I would maybe put 4 on the front and 4 on the back if you need a lot of space. But you need to write them all this way. I didn't have enough width to fit the questions on the board. None of these can be factored. You got to do it the long division way. The homework that was due today will just wait until tomorrow because there's too many kids out first, second, and third period. And then we'll grade this tomorrow as well. I will not do a new lesson tomorrow. There's way too many kids out tomorrow.